In Chapter 5, we're going to be writing linear equations. And this is going somewhat the reverse of Chapter 4. In Chapter 4, you would start with an equation and then graph it. Chapter 5, you'll be given some information or you'll be given a graph and you'll be asked to write the equation. And we'll start in section 5.1 with looking again at slope-intercept form. So remember that slope-intercept form looks like this: y equals mx plus b, where m is the slope and b is the y-intercept. So we started with an equation, and then from that we found the slope and y-intercept, and then we could draw a graph based on that information. So as I just said, we're going to go the other direction. We're going to write an equation in slope-intercept form based on the slope and the y-intercept, or a graph of the equation where we have to determine the slope and the y-intercept, or from the coordinates of 2 points on a line. And in that case, again, we're going to have to determine the slope and the y-intercept. So we'll see some examples of that. First case is the simplest case. Write an equation of the line with slope 4 and y-intercept -5. So we have y equals mx plus b, and we're told that m, the slope, is equal to 4, and the y-intercept b is equal to -5. We simply substitute those values into this equation. And so we get y equals 4x minus 5, since b is negative. Number 2, write an equation of the line shown. So here we want to determine the slope and the y-intercept. And I would suggest typically it's going to be easier to find the y-intercept first. So here we're at 0, -1, -2, -3 is the y-intercept. And then from there, we want to find another point on the line, preferably one that's at the intersection of two grid lines, like here, or let's go ahead and go here. And remember, in this case it doesn't matter, but very often we're better off picking points that are further apart rather than close to each other. So here, if we look at the rise over the run, or you can look at y2 minus y1 over x2 minus x1, either way, we're going up 1, 2, 3, and to the right 1, 2, 3, 4, 5, 6. So up 3 to the right 6 will simplify to a slope of 1/2. So now that we have the slope and the y-intercept, we can write our equation. Y equals 1/2 x minus 3. And so now for any given value of x, we can calculate what the value of y would be. And number 3, write an equation of the line that passes through the points -14, 3 and 14, -11. And here's a case that involves a little more work. We need to determine the slope first. And so we can look at either point as being point 1, point 2, it doesn't matter. Let's say I decide to start with 3 for my value of y. So y2 minus y1, so 3 minus -11 over, and because I started with 3 as my value of y, I must start with -14 in the denominator for our value of x. So -14 minus 14. So 3 minus -11 will give us 14. Remember, that's like adding a positive. And -14 minus 14 means we're going even more negative, which gives us -28. 14 over 28 will simplify to 1/2, and then because of the negative, remember we can put the negative either out front in the denominator or in the numerator. For slope, it's generally advisable, I would say, to put it in front. So our slope is -1/2. So now to find our y-intercept, we know that we're going to have an equation that looks like this. Y equals -1/2 x, but we still need to determine what b is. So what we can do is take either one of these 2 points and substitute the values of x and y. So here's a value of x, here's a value of y. And if we pick the 2 points from any ordered pair that is on the line, then this will work. Some points will be easier than others, but in this case we don't have a whole lot of choice, only two options. So here I'm going to substitute y is equal to 3. So 3 is equal to negative 1/2 times x is negative 14 plus b. And then we want to solve for b. So we can simplify here. 3 is equal to negative 1/2 times negative 14. Well, 2 will go into 2 once. 2 will go into 14 7 times. So we have negative 1 times negative 7 is 7, positive 7, plus b. So let me rewrite that over here. 3 equals 7 plus b. And to get b by itself, we want to subtract 7. That's a positive 7, so we subtract 7, and we get negative 4 is equal to b. So I just rewrote this up here. So now we have the value of m and the value of b. We can write our equation. Y equals m is negative 1/2 x plus b. B is negative 4, so I'm going to say minus 4. Y equals negative 1/2 x minus 4. Number 4, write an equation for the linear function f with the given values f of 0 equals 7 and f of 2 equals 17. So this is just a little notation. When we say that f of 0 equals 7, what that means is y equals 7 when x equals 0. In other words, f of 0 means 0 is the input, and then the value of the function is the output at that point, which is 7. If you want, you could make a little table here where you have, you could call it x, and then f of x, which is the same thing as y. When x is 0, f of x is 7. When x is 2, f of x is 17. Okay, so now we need to find our slope. So slope is equal to, and again it doesn't matter, you have 0.1 or 0.2. Let's go ahead and take 17 minus 7. So we're comparing the y values, or the function values in this case. 17 minus 7 over, and because I started with 17 on top, I have to start with the 2 in the denominator. So 2 minus 0. 17 minus 7 will give us 10. 2 minus 0 is 2. And then 10 over 2 will simplify to 5. So we know we're going to have y equals 5x plus b. And notice that we got in luck here because, or we're in luck because we have a value where x is equal to 0. So if we substitute these values, remember f of x is the same thing as y. So I'm going to substitute 7 is equal to 5 times 0 plus b. But 5 times 0 is just 0. And so on the right hand side we have 5 times 0 is 0 plus b is b, and we have our value of b equals 7, giving us the y-intercept. So the equation is y equals 5x plus 7, or you could write f of x equals 5x plus 7. These are equivalent. The notation in the second case, though, follows the notation we were given in the problem. So that's probably a better choice, actually. Okay, number 5. A hiking club charges $30 to join the club and $10 per hike. Write an equation and sketch a graph to describe that relationship. Okay, so here we have a graph, and if you look at, we want our slope. Well, slope is rate of change, which is this $10 that we're getting charged per hike. So slope is, if you want to write the units, $10 per hike. Notice that needs to be a unit rate. We'd like to see it as a unit rate per one hike. That's good. And then our y-intercept, b, is equal to the initial fee that it costs us just to join. So it costs $30 before we even take a hike. So that's our y-intercept. So we know that the cost, if we want to call this C, the cost is $30 plus $10 per hike. If we want to follow our normal slope-intercept form, we would write 10h plus 30. Okay, then to graph this, we want to look at, on the x-axis, the number of hikes. And we could pick whatever values we want here. We could start at 0, and how about if we just go by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, for example. And then here we're going to have the cost on the y-axis, and that's in dollars. Now remember, it costs $30 just to join. If we go on 10 hikes, we're going to be paying 10 times 10 is 100, plus 30 would give us $130. If we just go by tens here, we won't be able to graph all the way out here, but that's okay actually. So I'm going to go with 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So we know that it costs $30 just to join, so there's our y-intercept. And our rate of change, in other words, the slope is 10. So as we go up $10, we get to take one more hike. Or if you wanted to look at it this way, to go on 2 hikes would cost us $50 and then $60, and we keep going up by 10. Now, should you join these dots, these points, should you connect the points? And this is another one of those cases of discrete versus continuous. And the question is, can you go on, say, 1.5 hikes? And of course the answer is no. So this is a discrete problem, which means I'm going to go ahead and leave these points as they are. Now, I'm not going to, well, it depends on the problem. I probably wouldn't dock you points if you connected these and made a line. But you do at least see the pattern here, hopefully. And we just want to point out that you can go on, let's say, 2 hikes or 3 hikes, but nothing in between. We can't go on 2.1 hikes, for example. Okay, so there you have some examples of how to write linear equations using slope-intercept form. Good luck.